Hi all, what we see here is another piece of junk that I found, and a minute before throwing it away to garbage I said, hey, why not upgrade it a little. So this is a regular light lamp, and it was very easy to open it up because no screws. You just open the cover and then a few clips and ta-da, and you get all the electronics out. And the problem with this, I've already disassembled this lead acid battery, 6 volt, not 9, and 4.5 amp hour. And problem with this is that it doesn't really hold charge for a long time. This means that if you do not supply charge, and also the lifespan of such cells is very limited, and it will not last if you kept it in your closet for 1 year or 2 years. You cannot really expect that it work anymore. So of course the solution for this is use the lithium cells and not using this lead acid battery. So what I found is 4 cells from electric scooter, the ES2 of 9 volt. And when disassemble the battery, I don't always disassemble each cell, and I keep these cells the way they are built because of things like that I don't need to connect cells if it's already connected. So now why not use the connection that you already have in the cell? So the only thing is, of course, to use a BMS, and I will connect BMS. Next thing you want to do is to check that your LED will not burn out. So how do you do it? You just find an accurate power supply that you can control the voltage or maybe the current if you want to be more careful, and then you connect your old battery connection to this power supply, and then of course we will apply voltage and see what happens. Worst case, the lamp will burn away. So I'm starting with 6 volts. This is the original voltage, and yeah, I can see that the current is 0.5 amp. And now if the BMS batteries will be fully charged, of course it will be 8.4. So I'm testing it for 8.4 volts, and you see the LEDs are very bright. In this case the current is 0.7 amp, but they are not hitting, and current looks like it is stable. We will test it for maybe a few minutes to see that the current doesn't go up or doesn't fall down, or something happened to the current flow. And if it is stable for at least 10 minutes or so, we can say that we will be able to assemble these cells instead of the lead acid, and then you will have a lamp that will work forever probably, because these cells can hold charge for many years if you are treating it properly. So I will keep it working for 10 minutes as I claim that it will be good enough, and I will test to see that I don't have any current that goes up, and I will use a BMS. The BMS that I found for 2 cells, this is 2 cells, yeah, you can count 1, 2, 2, 2. Why is this? Because we have 2 cells in parallel, so 2 cells are like 1 for this BMS. This is what it means. And the way to connect it is very simple. You have a B plus to the positive and B minus to the negative of the cell, and BM. M is the middle between the first cells, the first 2 and the second 2, so it will be here, of course, where all the cells are together, and the output is P plus and P minus. And that's all. I will connect everything and connect this BMS. And after connecting, I like to add a fuse just to be on the safe side. And I also like to test it, which means I will overcharge the cell to a 9 volt to see that the BMS is disconnecting the charge, because I don't want something to happen when it is left overnight or too long. So I will do it, and then we'll see how it looks when it is all finished. Okay, so this is how it looks. A very simple design. So the BMS is connected. You can see directly to the plus of the cell, and the minus is connected with a fuse of 5 amp. This is a mini fuse, and the middle is going here to the other side, and this is the output. And I always like to keep it like this, so it is isolated till I will connect it. And the best thing is, of course, to add a Kapton tape around all the cells, or to use heat shrink that you can buy on AliExpress, on any other way, and it will fit, and the battery will be protected. Now let's try to see what is the voltage out. Yeah, and this is an interesting way. This is why I'm showing it. And we have a 0 volt, although the cells are charged. Yeah, I will show you. This is one cell, this is the second. So here comes the question, why I have 0 output, and the answer is very simple. All the BMS have some let's say protection, that they doesn't start till you supply charge to the cells, and even if you supply for a very short period of time, it will automatically turn on, and from that point it will be on. So I will demonstrate this. So I'm supplying now, I have here 8.2 volt. So I now will connect the positive and connect the negative, and you need to do it just for a second, and then your BMS is on. Yeah, okay, I can already disconnect it, and I will show you that now we have a voltage. Again, now I don't want to show it because this BMS will not handle the power of these cells, because it says it can supply 20 amps and the BMS is still 4 amps, but this is okay for this purpose. And you can see now we have a voltage. So this is all about. Now what another thing I will do, of course, I will charge it to maximum in order to see that the protection circuit actually works. And at this stage I will seal everything and connect it to the LED lamp, and that's all. Okay, so the protection circuit does work, and I will show you. I will now apply a charge to the battery. What you can see is the voltage on the battery here, and the current of the charging, 2 amp. And when it will reach 8.6 volt, which is apparently 2.3 to each cell, you will see that the current decrease immediately. You will see it very shortly. You see, not yet, it is exactly now 4.3 volt to each cell. So when it will reach a little higher than 4.3, the BMS will stop the charging, should stop it soon. You see the voltage drop and the current dropped, and now the voltage will be back just when the charge voltage will come to be lower than 8 volt or something. So we can confirm that the BMS is working perfectly. Anyway, this type of BMS, you can see how it looks like. It's called 2SA18 of HXYP, again 2SA18. So I can confirm that the BMS is safe to use, and I have voltage and a fuse on the voltage, so everything is perfect to go now. So last thing is, of course, to put a Kapton tape on all the batteries so it will be isolated anyway, and to connect everything back here. Yeah, positive and negative. And also to put some Kapton on all the connections. Again, you want to isolate everything to prevent any short. Kapton tape is a very good thing because it can suffer heat, or it is heat resistance, and it is very good tape for isolating things. So I use it a lot. You can also, of course, use heat shrink or whatever isolating tool you have, but I like this one. So now I can know that even if I charge it from outside, it will be perfectly okay. There are some screws, maybe I can use them in order to catch the battery somehow. Or maybe I can just glue it with hot glue gun, or something like this. So the battery will fit without any issue. You see, just in place. You can put it something like this, and maybe you can use this plastic somehow. Yeah, I have an idea. We can put something like a sponge or something that will catch the battery with some resistance. Yeah, something like this. Maybe I can do it a little smaller. Can use some cartoon or something, whatever you like, it doesn't really matter, just to catch it. And maybe try not to put it on, not to close the screws on the wire, of course, in order to prevent short, although I know that I have protection anywhere. Yeah, something like this. Need to get to the other side of the screw somehow, and I'm on the correct position, I guess. Yeah. And now this was put here, something like this, not very smart, but anyway, this is how it was. Can light it off. Yeah, this was here, just like this. And we have a brand new lithium light that can last forever because of the cells. So I will mark it as lithium, and it is about 5 amp hours, and the voltage need to be 9 volt to be on the safe side on the charging, although I know that the BMS will cut the charge if it will be higher. This is the project. Hope you enjoy. Thank you and bye.